Hi all, this is Kamal Kumar, Assistant Professor EEE from KPR IIT. In this video lecture, we are going to see about variable voltage, variable frequency control of an AC motor like induction motor or permanent magnet synchronous motor. Generally, this induction motor or permanent magnet synchronous motors are usually used in applications like elevators and escalators. Assume a PMSM or an induction motor is used as a motor for the elevator. So, where the requirements of an AC motor is to provide a soft starting and stopping at the floor level, and also it has to travel at various speeds. Okay, so at the initial starting time it has to accelerate because it has to carry a heavy load. It has to accelerate, and then between the floor levels it has to move at a constant speed, and then when it is going to stop, when it is going to approach the next floor level, it has to decelerate and it has to stop at the particular floor level without any millimeter level change in the floor level. So that is the basic requirement of an AC drive in case of an elevator application. So let us see what are the components present in a drive system, AC drive system. So in order to achieve this adjustable speed and a soft starting and stopping of a AC motor, we require a variable voltage, variable frequency drive. It is one of the most popular drives that are implemented in various industrial applications. Let us see what are the components of a variable voltage, variable frequency drive. Generally, the variable voltage, variable frequency drive has four major components. First is an three-phase rectifier unit. The second part is an intermediate DC link which consists of inductors and capacitors. And then the third important part is the three-phase inverter unit. And the fourth component is a microcontroller based control logic circuit. Okay, let us see one by one of the blocks of a variable voltage, variable frequency drive system. First, let us see about the first component, which is a three-phase rectifier unit. Generally, a three-phase rectifier unit consists of 6 switches, and the switches can be of unidirectional or bidirectional in nature. When they are using as a unidirectional converter, generally the switches are made up of diodes. Diodes are uncontrolled devices, so the rectifier unit does not have a voltage control. Okay, so whenever we want a variable voltage, it is generally preferred to have a SCR or IGBT-SS switches for your three-phase rectifier unit. The three-phase rectifier unit converts the given three-phase AC supply into a three-phase AC supply into a DC supply. The DC supply is an unfiltered DC supply. It consists of ripples. Okay, the output of the rectifier unit is actually applied to the intermediate DC link. The intermediate DC link is basically consists of inductors and capacitor. The inductors are basically to filter the ripples present in the output waveform of the rectifier unit, and capacitor actually stores. So the main purpose or the functionality of the intermediate DC link is to filter the ripples, store the DC power, and then deliver the DC power to the inverter unit. Next, we will see the functionality of a inverter unit. So this inverter unit basically consists of 6 switches. Okay, basically you all know what is meant by an inverter. An inverter is a circuit that converts the given DC supply into a AC supply. Here we want a variable voltage, variable frequency supply. Generally, whenever we want to change the supply voltage frequency, it is really difficult, because to convert the speed of an AC motor, okay, to change the speed of an AC motor, it is generally, there are only two options, because the speed expression, you all know the synchronous speed ns is equal to 120 f by p, where f is the supply voltage frequency and p is the number of poles of the AC motor. So it is generally difficult to change the number of poles of a motor. So the only option to change the speed is changing the supply voltage frequency, but changing the supply voltage frequency is not that easier. So we need to have a inverter unit to convert the frequency. Okay, to change the frequency, we are going to provide a varying firing pulses to the SCR switches, semiconductor switches, and the firing pulses are generated by the microcontroller unit that is present in the drive system. So the firing pulse pattern is generated by the microcontroller unit, and it is generated such a way that the output of the inverter unit is a pulse width modulated AC supply. So we all know what is a pulse width modulation. It is basically the width of the pulse is varied. So the output is a pulse width modulated waveform, and if you take the average voltage, it will be similar to the sine waveform as shown in the output waveform. So now you have a pulse width modulated AC supply as an output from the inverter unit. This is fed to the either the induction motor or the permanent magnet synchronous motor. You all know synchronous motor runs only at synchronous speed. Okay, when we want to change the speed of the motor, we want to maintain the V by F ratio constant. So that is achieved with the help of this VFD drive. So the main feature of a VFD drive is an adjustable speed and soft start and stop capabilities. So this is the basic requirement for any industrial application like an elevator or escalator. So as we have discussed, the rectifier unit consists of minimum of 6 diodes for a 3-phase conversion. So the rectifier is also called as a 6-pulse converter, and the switches can be either diode or transistor or SCR. Okay, so the output is a DC power, and the DC power output can be varied when we use a bidirectional switch like SCR with the help of a gate control, that is the pulse is triggered by the microcontroller unit. And the DC bus main function is to receive the DC power, remove the ripples and store it in the capacitor, and deliver the DC power to the inverter unit. Similarly, the inverter has 6 switches. Okay, the switches can be made up of SCR, IGBT or transistors. The main functionality is to receive the DC power from the DC link and convert it into a AC power and deliver it to the motor. While delivering the AC power, it uses a modulation technique called pulse width modulation to vary the output frequency. The control unit basically is to provide the firing pulses for the rectifier in the inverter unit and configure basically the drive settings and receive the feedback signal from the motor and regulates the voltage and frequency accordingly to change the speed of the motor. It also has some interface provisions for various communication protocols, and generally the microcontrollers are 32-bit RISC controllers like Atmel Mega microcontrollers, STM32 microcontrollers, etc. And PIC series 16F and 18F series can also be used as a microcontroller for a VFD drive. And generally this VFD drive is also used in our home. Okay, for BLDC motor control they use this VFD drive. That is one more additional application of this VFD drive. So it is also called as V3F drive control. Okay, so variable voltage, variable frequency control. So while implementing the VF3 control, we have 6 switches as we have seen in the diagram. Okay, and the switching pattern that is generated by the microcontroller unit here should be in such a manner that both the upper arm switches and the lower arm switches of the same leg are not turned on at any instant of time. If it is turned on at the same instant of time, it will get short circuited. So generally it is avoided. Okay, so that is one of the precautionary step for the controller unit. And generally the transistors are going to be switched around at a speed of 5000 to 6000 times per second. So such a heavy switching is taking place to control the speed of the motor. That is a typical speed, that is 5.5 kilohertz to 6.5 kilohertz. Okay, so pulse width modulation is basically changing the width of the pulse according to the requirement. So here between each pulses there will be some dead time. Okay, so that dead time will be 5 to 7 microseconds, such a way that there won't be any short circuit. And you could see when the speed has to be narrow, the voltage should be reduced. So in order to reduce the voltage, the width of the pulse is narrowed. When you want to increase the speed, the average voltage should be higher. So the on time of the switch is higher compared to the off time. This is how we are going to achieve the pulse width modulated waveform. So in order to change the speed of the motor, we are actually changing the time period, that is the frequency. And when we want to change the torque, we are going to change the voltage of the AC motor drive. Thank you.